Hello, smart mathematicians. Welcome to our lesson on congruency. Right, in the previous lesson, we managed to discuss a similarity. And then in this lesson, we're going to look at what? Congruency. Right, what is the difference between congruency and similarity? Remember, similarity say that the shapes have different sizes, but the angles there are the same. And then the sides of the shapes are proportional, not equal. They are proportional. When it comes to congruency, the polygons have the exact same shape and size. They are just the exact thing. They are just the same. They are just the same. Okay, that's congruency. And then corresponding sides are the sides that are in the same position relative to the angles of the shapes being compared. Right, when you talk about corresponding sides, corresponding angles, we talked about those when we're looking at what? At similarity. Right, two triangles are congruent if what? If they have exactly the same shape and size. Like these two triangles here, triangle ABC and triangle DEF, they have the same shape and the same size. They are congruent. We say they are congruent. Okay. They are able to fit exactly on top of each other. We say they can be superimposed. Like when you put your right hand on top of your left hand. You see that? They are superimposed. They can just fit exactly on top of each other. This means that all three corresponding sides and three corresponding angles are equal. So the sides are equal. The corresponding sides are equal, not proportional. They are equal. And then the corresponding angles are equal also. Right. We have angle A and angle F are equal. Do you see that? Angle A is equal to angle F. Okay. And then angle C is equal to angle E. And then we have angle B being equal to angle D. You see that? So the corresponding angles are equal. And then if we come to the sides also, we can see that AC, we're given that AC is equal to EF. They are equal, not proportional. And then which other side? We have BC. BC is equal to what? BC is equal to DE. Okay. And then AB is equal to DF. AB is equal to DF. Right. So the corresponding angles are equal and the corresponding sides are equal. Okay. Now let's talk about the four conditions, the minimum conditions for what? For congruence. Condition one, if we check these two triangles, let's say in triangle ABC and triangle FDE, right? What can we say? Right, we have AC is equal to EF. Now I want to write like everything and write our reasons. AC is equal to EF. So the reason here we say is given. We're given that AC is equal to EF. Using that, these symbols here, we can see these symbols there. And then we have BC. BC is equal to BC is equal to DE. BC is equal to DE. It's given. And then the last one, AB is equal to DF. AB is equal to DF is given. Okay. Right, then what can we say from here? We can say therefore, triangle ABC is congruent. You see that? So these sides here are for triangle ABC, and then these sides here are for triangle FDE. Okay, so triangle ABC is congruent to triangle what? Let's check the movement. I move from A, it says AB. So A to the along the line with what? With two markings. You see that? AB along the line with two markings towards the line with three markings. So I must do the same thing here. I must move along the line with two markings towards the line with what? With three markings. So it's AB. So it should be FD, sorry. So it's AB, it should be FD. You see that? Okay, let's move again. AB and then C. So it's along the line with two markings, and after that along the line with three markings. So it's ABC. So I do that along the line with two markings, and then along the line with three markings. You see that? So it's FDE. You see that? So triangle ABC is congruent to triangle FDE. Okay, right. Try to follow that. The arrangement is very, very important. You cannot just write anyhow. I cannot say a triangle ABC is congruent to triangle EFD. No, it's not. I have to follow the correct arrangement. So triangle ABC is congruent to triangle FDE. Okay, and then we put our reason. Then we put our reason, which is side, side, side. Okay, because it corresponding sides here, corresponding sides here, corresponding sides here. That's the first condition for congruence, the minimum condition. If you prove that the three corresponding sides are equal, then means the two triangles are what? Are congruent. Okay, right, let's move to the second condition. Right, second condition, we have two triangles. Again, we're going to be using the same letters. So in triangle ABC, and triangle, and then in triangle FDE, this is FDE. Right, what do we have here? We have AB. AB is equal to what? AB is equal to FD. AB is equal to FD. Is given, right? And then we move to, we have angles here. We have angles. So angle A is equal to angle F. That is given. Everything is given here. Okay, right. And then we have the side AC is equal to FE or EF. AC is equal to EF. Right, given. Right, okay. Right, now if we check, we have corresponding sides here, corresponding angles, corresponding sides. So we can say that therefore triangle ABC is congruent to triangle what? The arrangement of the vertices is very important. So AB, I'm moving along the line with two markings from an angle, from the angle that we're given, along the line with two markings, and then to the line which is what? Or to the side which does not have any marking. So I must follow that order. From the angle, along the line with two markings, and then along the line without any markings. You see that? So it's ABC and then FDE. So we can say these two triangles are congruent because of what? Side, angle, side. Okay, this condition, make sure that the angle is what? Is included. Included. When I say the angle is included, it means the angle is in between the sides. You see this angle, A here is between AC and AB, or is formed by AC and AB. And then angle here also is formed by FD and FE. So we say it's an included angle. It's an included angle. So it should be side, angle, side. Nothing else. You can't have side, side, angle, or you can't have angle, side, side. No. That condition will not give us what? Congruency. Okay. It's not enough to show those other conditions like side, side, angle, and angle, side, side. They're not enough to show us that what? That the two triangles are congruent. So that's the second condition. So we've talked about how many conditions? Two conditions. Side, 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 angle, side, and then let's go to the third one. And then condition 3, what we have here, in triangle, we're basically using the same triangles. In triangle ABC, in triangle ABC and triangle FDE, we can see that, let's start with this angle B. Right, you can see that angle B is equal to angle D. It's given, right? And then we go to the angle A. Angle A is equal to angle F. It is given, right? And then we have side AC is equal to side EF, given. Right, so we can see that we have angle, two corresponding angles being equal, then corresponding sides being equal there. So we have angle, side. That's another condition. So therefore, triangle ABC is congruent to triangle A, moving from this angle B towards the right angle, and then C along the line which is not marked there. So it's FDE. Let me try to rearrange these vertices and then see. Right, let's say the reason here is angle, side, angle, side. Right, and then I was saying, let me say I said triangle what? BAC. It will be congruent to triangle which triangle? I can't say FDE here. I have to follow this. So BAC. I have to follow this and say DFE. You see that? From this angle, the red angle to the blue angle, and then along the marked line. So it's BAC. So I must follow that. DFE. See that? So this one is going to be DFE. Right. Let's discuss and see what we can get from this congruency. So it's angle, side. Why is the arrangement very important? Like from this, you can see that angle A is equal to angle F. See that? Angle A is equal to angle F, like here. You see that? Even when I come here, I can see A second position, F second position. I can see that angle A is equal to angle F. Then angle B is equal to angle D, like here. You see that? Okay. And then even here we can see angle B is equal to angle D. Right, angle C is equal to angle E. You see, angle C, this angle is equal to this angle. You see that? From congruence you can see that. Even the sides, AB is equal to FD. Even here, AB, which is BA, is equal to FD. BC is equal to DE. Then BC is equal to DE. You see that? And then the last one, AC is equal to FD. AC is equal to FE. AC is equal to FE. AC is equal to FE. You see that? So it is very, very important to arrange your vertices correctly so that from congruence, you can find which angle is equal to which angle. You can also find which side is equal to which side. Okay, let's do the last condition. And then these two triangles. So in triangle ABC and triangle FDE. Right. So what are we given here? You're given angle A, angle F. Angle A is equal to angle F, and then both of them are equal to 90 degrees. So it's given, right? Okay. And then angle BC is equal to, this is a right angle triangle if you check. BC is equal to what? Is equal to DE given. And then we have AB is equal to DF. AB is equal to FD or DF. Right, given. Right, so we can conclude and say, therefore, triangle ABC is congruent to triangle FDE. Right, and then what's the reason? We have a right angle, then hypotenuse, side. That's the reason you write there. Right angle, hypotenuse, side. Right, so if you check, we have done our 4 conditions. We said side, 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 angle, side, angle, angle, side, and right angle, hypotenuse, side. Those are the 4 conditions that can prove that the two triangles are what? Are congruent. Right, okay. So now, is this pair of triangles congruent? Give a reason for your answer. Is this pair of triangles congruent? Give a reason for your answer. If you check here what we have angle B. Angle B is equal to angle D. It's given. Right, okay. Right, and then we have AB is equal to DF given. We have AC is equal to EF given. But now if we check here, what we have angle, side, side. We have angle, side, side. Is this condition enough to show us that these two triangles are what? Are congruent? No, it's not. Okay, so we say that, okay, we cannot confirm and say these two triangles are congruent because we're talking about what? Side, side, angle, or angle, side, side. And then this is not enough to prove that the two triangles are what? Are congruent. Okay, remember it should be side, angle, side. It should be side, angle, side. The angle must be included. The angle must be included. Okay, the angle must be included. Remember that. Let's do this small activity. Right, write down the equal angles according to the following statement. Right, we're saying triangle ABC is congruent to triangle DEF. So from here we can conclude and say. Angle A is equal to angle D. Angle A is equal to angle D. What's the reason? Congruency. From congruence, we can see that angle A is equal to angle D, and then angle B is equal to angle E. Angle B is equal to angle E. Then the reason, even if you say congruence, let me just change this thing here. Congruency. Okay. Right, some books use Y, some books use E. It's fine, let's leave it like that. And then see here, so we have angle C is equal to angle F. Okay, you can even write like this, is fine, because triangle ABC is congruent to triangle DEF. Okay, so if you write this or this is still fine as your reasons. Okay, so you see that's why it is very important for you to write these vertices in what, in the appropriate order, so that you can deduce from the congruency which angle is equal to which angle. Okay, even the sides, write down the equal sides according to the following statements. So we can say that AB is equal to DE, AB is equal to DE. Okay, right, congruency. And then BC is equal to EF, BC is equal to EF, right, congruency. And then AC is equal to DF, AC is equal to DF, congruency. Okay, so some people say this is like a smiling face with what, the eyebrows and what, and the smile there. You see, it's like this. So if you remember this eyebrow, the smile. Okay, so from congruence you can find which sides are equal. You see that? Okay, that's why it is very, very important for you to write the vertices in the appropriate order. Right, given triangle ABC and triangle PQR, we're given that angle A is equal to angle P, and then angle B is equal to angle Q, and then angle, is it angle A? No, should not be angle A here. Angle C. Angle C is equal to angle R. Right. So now, is this pair of triangles congruent? Give a reason for your answer. Okay. If you check here, we have angle, angle, angle. Is it enough to show us that the two triangles are congruent? No, we cannot say they are congruent. Okay, they may be congruent, yes, but this condition is not enough to prove that the two triangles are congruent, because it's just angle, angle. We don't have this condition for congruency. We have side, 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 angle, side, and then angle, angle, side, and then right angle, hypotenuse, side. And then this one is for what? Remember, this one is for similarity. Okay, similarity. Similar triangles are equiangular. Remember that. So this is for similarity. They may be congruent, but we cannot conclude from this condition. We cannot conclude and say, yes, definitely, these are congruent. No, we can't. But these are similar. Okay. Right. So we've done that part. ABCD is a kite in which AB is equal to AD. AB is equal to AD, and BC is equal to CD. We can see there with those markings. Prove that triangle ABC is congruent to triangle ADC, and then why is BC equal to DC? Right. So now we are saying in triangle ABC and triangle ADC. So what we have, let me see, in triangle ABC and triangle ADC. What we have AC. AC is equal to AC. Y equal to AC. That's a common side if you check for the two triangles. That's a common side. And then BC, let's start with triangle ABC and then followed by ADC. Right, and then BC is equal to DC is given, and then AB is equal to AD is given. Okay, right. And then now we can conclude and say, therefore, triangle ABC is congruent to triangle, right? ABC along the line with one marking, then along the line with two markings. ABC. So we do the same thing along the line with one marking, then along the line with two markings. So it's ADC. You see that? Congruent to triangle ADC. Proved. We've managed to prove that. And then what we have here, side, side, side. Side, side, side is our reason. Okay. And then the second part says, why is BC equal to DC? From congruence now, we can conclude and say BC is equal to DC. So we say BC is equal to DC. Why? Because triangle ABC is congruent to triangle ADC. Okay, and then you can also see that AB is equal to AD. You can also see that AC is equal to AC. See? Okay, right. Let's do this question. PQ is parallel to RS. You can see that it's indicated here. And then QT is equal to TR. We are required to prove that PT is equal to TS. So we can prove that PT is equal to TS using congruency, even that PQ is equal to RS. So let's use congruence for this. Right. So PQ is parallel to RS. We have to think about the geometry of parallel lines, that is alternate angles, and then we talk about corresponding angles, cointerior angles. So here we have alternate angles. Angle P is equal to angle S. Okay, which triangle are we referring to anyway? We're talking about triangle. In triangle P, Q, T, and triangle SRT. I'm trying to match the vertices, although I'm not sure. I will just prove it and then see, but I'm trying to match randomly. Right, so we said angle P is equal to angle S. Angle P is equal to angle S here. It's alternate angles. Since PQ is parallel to RS. Okay, right. And then we go to the other one also. Let's start with triangle PQT followed by triangle SRT. And then angle Q is equal to angle R. And then angle Q is equal to angle R. Right, again, alternate angles. PQ is parallel to RS. And then we have the sides here. QT is equal to RT. Okay, we're given. Right, so therefore triangle PQT is this triangle PQT, right, is congruent to triangle what? Then PQ, we're seeing from this angle with one marking here for the angle towards the angle with two markings. You see that? So it's PQT and then two T there where the angle is. Okay, along the line with one marking. So let me start afresh. So it's from the angle with one marking here towards the angle with two markings, and then along the line with one marking here. You see that? So it should be the same thing from the angle with one marking for the angles towards the angle with two markings, and then along the line with one marking. So it should be congruent to triangle SRT. Okay, and then the reason here saying angle, side. You see that? angle, side. That is enough to show us that triangle PQT is congruent to triangle SRT. And then from here, we can see that PT is equal to ST or TS, isn't it? So therefore, PT is equal to TS. Why? Congruency. Since triangle PQT is congruent to triangle SRT. And then PQ, again, we can see PQ is equal to RS. Then since triangle PQT is congruent to triangle SRT. Okay, right. So you've managed to prove that. So it's because of angle, side. Right, let's move on to the next one. In the following diagram, O is the center of the circle. BO bisects angle AOC. Prove that OB bisects AC at B. So if we're saying OB bisects AC at B, it means we have to prove that AB is equal to BC. So here we're basically proving that AB is equal to BC. Okay, so we have to use congruence for that. Okay, so what do? BO bisects AOC. So it means here, from that we can conclude and say, therefore, it means O1 is equal to O2. O1 is equal to O2. So it means when it's bisecting, means it's cutting the angle into two equal parts. You see that? That's what is meant by bisecting there. So it means we can say here, in triangle ABO and triangle CBO, right, angle O1 is equal to angle O2, right, is given. Okay, and then we have OB, which is a common side. OB, which is a common side. So OB is equal to OB. It's common. Okay, and then we have OA and OC. What can you say about OA and OC? OA is equal to OC because they're what? Radii. Okay, radii. Right, this OC is from the center to the circumference. OA from center to the circumference, so they are equal. So now we can conclude and say, therefore, triangle ABO is congruent to triangle what? From A then to the center, which is B. You see that? Along the unmarked line, and then along the common side. So it means ABO, triangle ABO is congruent to triangle CBO. Okay, CBO. Then what's the reason? We have what? We said this is the side, and then the angle, and then side, the common side. So it's because of side, angle, side. You see that? So we've managed to prove that the two triangles are what? Are congruent. Right. So now, if the two triangles are congruent, it means what? It means angle B1 is equal to angle B2. Therefore, angle B1 is equal to angle B2. Why? Because triangle ABO is congruent to triangle CBO. See that? Right. So now, when these two triangles when these two angles are equal, we can prove that OB is perpendicular to AC. Okay, because these angles are adjacent angles on what? On a straight line. Okay, so now we can say angle B1 plus angle B2 is equal to 180 degrees, right? Adjacent angles on a straight line. Adjacent angles on a straight line. And then since B1 is equal to B2, so you can replace any of these. Okay, so you can say 2b2 is equal to 180 degrees. So I've said let b1, okay, b1 is equal to b2, so like angle b2 plus angle b2, which is 2b2, is equal to 180 degrees. Then divide by 2 both sides, so angle b2 is equal to 90 degrees. See that? So we've proved that this angle is a right angle, and then we say these two angles are equal, so it means this one also is a right angle. So we've proved that therefore OB is perpendicular to AC. Okay, right, we are done. So that's congruency. We're going to use these concepts when we're doing what? When we're doing Euclidean geometry. It is very, very important that we revise these two concepts, similarity and congruency. Let's meet in our next lessons. Goodbye.